In this video, we're going to take square roots a step further. Instead of just simplifying our square roots and our square root expressions, we're going to put an equal sign in there. Whenever I put an equal sign in there, that means we no longer have an expression, but we have an equation. So things are a little bit different here, but also a lot the same, and it's actually kind of combining a few of ideas that we've been working with all year and that we've just learned. So, operations have opposites. We've known that since 8th grade, since Unit 1. Adding, the opposite is subtracting. Multiplying, the opposite is dividing. We've solved loads of equations this year using those concepts. Today we're going to start solving with the opposite of squaring, which is what we learned on our previous video, and that's square root. So, what does that mean? That means if I have x squared equals 9, I don't have x by itself anymore. Just like if it was 2x equals 10, I would divide both sides by 2, because multiplying and dividing are opposites. X squared, I can undo by taking the square root. Those are opposite operations, but anything I do to the left side of my equation, I have to do to the right side. So at the end of the day, that square root and that exponent of 2 cancel and leaves just x here. Same idea as 2x equals 10. Divide by 2, those 2's cancel and leave me x, as long as I divide by 2 on the other side, and x was 5, but now I'm taking the square root on this side. So, first, we check our calculator, and yes, square root of 9 is 3. So that says x is equal to 3. But be careful, is there really only one answer to this? In fact, there are two. Because this is no longer an expression, and it's an equation, we have to consider the fact that there are actually two different numbers that I can multiply by itself and get 9. The first one is the obvious, it's 3. The second one is not as obvious. Have you guessed it yet? It's negative 3. So we would actually say that this is x equals 3 or negative 3. The other way you will write this, and you'll see this written all the time, is plus or minus, positive or negative 3. Either of these would be acceptable answers. Because negative times negative is positive. Positive times positive is positive. This only happens in equations, not in expressions. So, let's take a look at a few other examples. If I have x squared equals 49, I can't get x by itself until I square root both sides. So x is equal to, the square root of x squared is x, square root of 49 is 7. Or negative 7. It's always the positive or the negative when I'm solving this equation. But in number 2, things are a little bit different, because when I square root both sides, I get x is equal to, well, square root of 8 is not a perfect square. 8's not a perfect square. That's when simplifying comes into play. I do not want decimals. You can see it straight in the directions here. No decimals. That means I need you to simplify this square root. Just like we did in our previous video. 8 is 2 times 4. That's 2 times 2 times 2. That's all inside the square root. But we do want a positive negative in front of this. Because it's an equation, we need to keep that. Pair of 2's. Pull that out. I already have a positive negative out in front. So I wind up with positive negative 2 square roots of 2. And let me just give myself some space here. That's what x is equal to. I'll do one more with you. Square root both sides. Square root of x squared is x. I square rooted this side, so I have positive negative. 18 is not a perfect square. That's when I have to simplify my square root. 18 is 2 times 9. That's 2 times 3 times 3. That's all positive negative, and it's inside a square root. I have a pair of 3's. Pull the 3 out, it's positive negative 3. I have a 2 left over inside, it stays inside. x equals positive or negative 3 square root 2. Try number 4, please. Pause, unpause when you're done. Did you get x equals plus or minus 2 square root 15? If so, great work. If not, go back and check your work. Now, is the plus or minus necessary? Absolutely. There's 2 answers to this, not 1, so if you just leave it as 2 square root 15, you will get the problem wrong. Now, when do we do this? We only do this when x squared is by itself on one side. So I'm not going to square root both sides of this equation yet, because I don't have x squared as the only thing on the left. So I have to keep in mind some of the things that we did first semester. Like, if I'm subtracting 6, I still add 6. That's no different than what we did first semester. It cancels here. X squared equals 16. Now that x squared's the only thing, I square root both sides. X is equal to plus or minus. 16's a perfect square. Square root of 16 is 4. X is plus or minus 4. In number 6, same idea, except I have that 2 there. Divide by 2 first. You have to get x squared by itself. X squared equals 12. Now that it's equal to 12, square root both sides. X is plus or minus. 12's not a perfect square, so it's square root of 12. I have to check to simplify it. 3 times 4 is 3 times 2 times 2. Plus or minus that inside a square root. That's a pair of 2's. So x is plus or minus, pair comes outside, 3 stays inside. Done. I want you guys to go ahead and press pause and try numbers 7, 8, and 9. 9's going to be a little trickier because there's a lot of steps, but try to get your x squared on the left, everything else on the right. Unpause once you're done with these 3, and let's check your work. So for number 7, hopefully we got to this point. First subtract your 120 from both sides, then divide by negative 6 on both sides. X squared equals 25. Now you can square root both sides. X is plus or minus. 25 is a perfect square. Done. If you haven't already done so, try number 8. So for number 8, you distribute your 2, add 48 to both sides, divide both sides by 2, then take the square root. 24 is not a perfect square, so you have to simplify it. Don't forget your plus or minus. I'm going to get number 9 started now, if you haven't already done so, and then we're going to move on. Now, I have 2 sides of this equation. I need, at the end, my x squared on this side equals everything else on the right. So the first thing I'm going to do is get my x squared on the same side, and that means subtract 2x squared here, subtract 2x squared here. That gets rid of it on the right-hand side. It leaves me with 2x squared minus 52 on the left. On the right, I also have like terms. These are on the same side. That's not inverse operations. That's combining my like terms. And that gives me negative 12. Now it becomes a problem like the first 2. Go ahead, pause, and finish this. So we should get x equals plus or minus 2 square root 5. Okay. Once we solve and get x squared by itself, it's equal to 20. Square root both sides. Simplify this. That becomes 2 times 10, or 2 times 2 times 5. So it's plus or minus 2 on the outside, square root 5 on the inside.